Hey everyone, so I am on Alex and this is kind of putting everything together here. This is the goal we're after, is looking at everything we've learned up to this point and then just doing kind of a few problems. I'm not going to do all kinds of problems because I've covered that with quite a bit of the other things and that would make this video way too long, but I am going to do a couple different kinds of problems so that you can sort of get a bit of a handle at it and also see kind of like what they're going to look like when you're working on them. So let's get started here. I'm in student view. Kind of a neat little feature. So this first problem, it says graph the parabola, and it gives me this equation. It says plot 5 points on the graph of the parabola. The vertex, 2 points to the left of the vertex and 2 points to the right. Then click on the graph a function button. So it tells you the first thing it wants you to plot is the vertex. Well, if you look at this, this is in vertex form, which is one of those newer things we just learned about, right? Vertex form is that x minus h plus k. All right? And so if this were x minus 4 plus 1, my point would be the point 4, 1. But because it's x plus 4, that means it's x minus a negative 4, and then it becomes double negative positive. So my vertex for this is going to be the point negative 4, 1. All right, negative 4, 1. So I'm going to go over, I'm going to grab my pointer tool, I'm going to go over to negative 4, I'm going to go up to 1, I'm going to plot a point. All right, and then we want 2 points to the left of the vertex, so over here, and then 2 points to the right of the vertex. Well, for me, it would make the most sense just to do like negative 5 and negative 6. So let's put negative 5 into that. So if you do that, you're going to have negative 5 plus 4 is negative 1. That squared is 1. 1 plus 1 is 2. So that would be the point negative 5, 2. And then if we do negative 6 plus 4, right, I'm just putting it right in here. Negative 6 plus 4 is negative 2. Square that. All right, that becomes positive 4 plus 1, which is 5. So we've got 2 points there. And then I'm going to cheat because I know this is the axis of symmetry because it's the vertex. And I'm just going to do a mirror image of these 2 points. All right. And if you don't believe it, you can check them out, but it works. Put in your graph align tool and then click check. And voila, there you go. All right, got a few more problems here. Look at these graphs. Fill out the information about the leading coefficients A, B, C, and D. All right, so this is my graph here. So if I look at this, I know that my leading coefficient for this one is going to obviously, there's going to be a negative in it because it's opening downwards. Same thing with this one. These two are going to be positive, although it's not necessarily that way. All right. And then I also know because of the kinds of dilations that are going on, this one is probably going to be a smaller number than this one. Because remember, if the larger the number is, the tighter the opening is, right? Because like y equals x is going to look like your normal regular curve, and then if you have y equals 2x, it's going to be more narrow. All right, it doesn't open up as much. I mean, it does over time, but it just goes up so much faster. All right, so let's take a look at this. So it says for each coefficient, choose whether it's positive or negative. A is going to be negative, right? That's what we said, and B was going to be negative. And then C and D are going to both be positive. All right. And then choose the coefficient closest to 0. So of these 4, I would say the coefficient that is closest to 0, in other words, the smallest coefficient would be this one. Because remember, the fractional coefficients are the ones that give you those wider openings. So we are going to say A. And then choose the coefficient with the greatest value. That means the biggest number, and that is probably going to be C because that has the tightest opening. All right, and so let's see how we did here. There we go. Okay, let's look at number 3. What do we got? Use transformations to get to the graph get the graph of y equals negative 1/2 x. So that's this. They're showing this, right? So the first thing we want to do is it's negative, right? So we're gonna want to flip this thing. So if I hit this one, it rotates it basically around this axis, which looks exactly the same because it's symmetrical. But if I do this one, it flips it down there, which is what we're after, all right? And now it's y equals negative 1/2 x. So that means that I'm going to use one of these two tools, and it's going to be stretched, right? We're going to be compressing it vertically, right? We're going to be making it go closer to the x-axis. So if I put in, think about this, if I put 1 in, that makes this negative 1/2, right? And so if I put 1 in, it's not going to be negative 1, it's going to be negative 1/2. So this tool is a little weird to use. So I'm gonna try it this way. And I seem to remember this being a little weird. And I'm going to go, no, yeah, that works. So I go to negative 1/2, right? Which is, I think it goes by quarters. And when I move it there, and then check it for 2, put 2 in. So if I put 2 squared in, right? 2 times 2 is 4. 4 divided by 2 is 2. And it would be negative. So that looks about right. So let's check this. Let's see. That one looks pretty good. All right, let's look at this next one. Use transformations. This graph of y equals 1/2 x. So this is a horizontal dilation because it's all within the parentheses and being squared. But remember, it's all basically kind of the same thing. Basically, it's going to make this thing much wider than it was before. So if you square 1/2, what happens is it becomes 1/4, right? So the parent function for this is y equals x squared. That's what they're showing right now. So this thing's going to be much wider open. So what we want to do is, if I put 1 in, it's going to be 1/2 times 1, and then you square that, and that will give me 1/4. So, and then before I do that, real quick, let's talk about this. Does this need to be reflected at all over the x-axis? No, because it's positive. So it's opening up the right way, which is what we want. So let's use our tool that way, and we're going to go down to 1/4, which I believe I should be able to get to. That should be here. And then if I put 2 in, 2 times 1/2 is 1, and square that, and that gives me 1. So this looks like this should be accurate. Yep. All right. 2 more. All right. Function g is defined as follows. If the graph of g is translated vertically downward by 3 units, it becomes the graph of a function h. All right, so all they're saying is we're taking this and we're translating it vertically downward by 3 units. Now remember, when you translate something vertically, you're adding k to it, right? You're adding a number off to the side to it. If it's positive, that means you're moving it up. And if it's negative, it means you're moving it down. So this means that we're taking this equation and we're basically subtracting 3 from it because it says vertically downward by 3 units. So if you think about that, that means our new one is going to be taking 5x squared and then minus 6, and then we're subtracting another 3 from that. And so they're not going to want us to leave this like this. They're going to want us to take that and combine that. So negative 6 and negative 3 combine to be negative 9. All right? And I won't check it with the graphing calculator because I want to keep these videos relatively short. All right, last problem here. All right, graph this parabola. So we got a lot going on here. So let's look at what we know. Well, I know the vertex, right? The vertex is going to be the point -4, -1. So that much I can put in, right? So I'm going to go over here. I'm going to put that point in. I also know that this is negative, so this thing is going to be opening downward. Okay? So I've got 2 really good pieces of information here. So now that I know the vertex, I'm just going to plug some points in. So if I put -5 in, so we'll do 2 points to the left of the vertex. If I put -5 in, that gives me -1 squared, which is 1, times -3, which is -3 minus 1, so -4. So we have this point. I apologize if you can hear all the racket going on. Now this thing's gonna get pretty crazy big pretty quickly because of that -3. Remember, that makes it really narrow and open up fast, right? So let's put in -6 makes this equal -2. If you square that, that's 4. 4 times -3 is -12, and -1 makes it -13. So like I said, this thing gets really fast. All right, and then we'll just do our trick of doing this symmetry on your axis of symmetry. Hit our line tool and then click check, and then you have just rocked this. So I hope this was helpful. You'll be doing some problems like this on your own. Please feel free to reference this, and thanks for watching, guys.